two classes, class 1, class 2. Okay, class 1 is going to be carboxylic acids, acetic anhydrides, esters, amides, etc. If we expose these to a strong base, it allows the leaving group to leave. Okay, and so we can easily do a substitution, kind of like an SN1 or an SN2 with these, okay? Because the carbonyls are attached to good leaving groups, right? If you notice the aldehyde and the ketone, there's no good leaving group there, okay? So they behave somewhat differently, okay? Good. And so really, what separates these two classes is the oxidation state of the carbonyl, right? Whether it makes it a good leaving group or a bad leaving group. So we'll talk about carboxylic acids probably next week. Today we're going to focus on class 2, okay? They don't have a good leaving group, and so they're going to have to do an addition reaction for the most part, okay? And you might remember, I think maybe last quarter, there was a reaction where if we take an aldehyde and a hydride, we can make alcohols. And then did Sean talk about keto-enol tautomerization?
Yeah, that sounds very familiar.
Okay. Tautomerization. See, that's why I don't make you memorize this stuff.
Because they like rearrange.
Yeah, it kind of goes back and forth between an alcohol and a ketone.
Okay.
It's an intermediate. Okay. So we'll kind of bring in those. So if he did discuss those, we're going to bring them back. All right. If he didn't, we'll talk about it. But this stuff should kind of be recycled to some extent. All right, so you folks know clearly what an aldehyde is and what a ketone is, right? And so aldehyde is a primary carbon, right? Because it just has this R. This one is secondary. And we can make aldehydes from alcohols. If you have ever consumed ethanol, if you've ever consumed a lot of ethanol, you may have had a hangover before, right? If you haven't had a hangover, then you've done good work.
It only gets worse when you get older.
Yes. What happens when you drink alcohol is that your body recognizes it as a toxin and it quickly activates pathways to break that toxin down into something else. Okay? And it does that at the expense of all your other metabolic processing. So people who consume alcohol tend to be less inhibited, right, behaviorally, and so they might eat more than usual, right? Or they might eat because we often have cocktails with food, you know, like our happy hour, or I gotta get a good base of food in my stomach because I'm gonna fill it with booze, right? So what happens is your body shifts its metabolism to purely breaking down the alcohol, and then the food that you eat gets stored as, you know, extra energy. The nutrients don't get bioabsorbed as well, right? And so, so alcohol isn't really a very good thing to consume, okay, for a lot of reasons. I'm not going to proselytize to you that you shouldn't drink alcohol, but if you do, and if you had a hangover, a lot of that is because alcohol gets broken down into aldehydes. And aldehydes can't be readily processed by the body. And an aldehyde could be ethanaldehyde, or it could be formaldehyde. And you know what formaldehyde is, maybe. We don't use it
Embalming.
as much anymore, but it's a preservative, right? It's a toxin also. So we're taking a toxin and we're breaking it down into other toxins, right? And so the next day you wake up and you're dehydrated, so that's also why you're feeling bad. And you have these aldehydes coursing through your system, which are poisonous too. Okay. It's just that we can't further break these down, the enzymes in our body. Ketones, right? So in the absence of carbohydrates, fats, lipids can be broken down into ketones. And that's the basis of the keto diet, right? If you don't eat sugar, your body will then start undergoing ketosis, and you will break down the fat in order to make sugar for ATP. Okay, and it is effective, right? So, I mean, I think people who are on the keto diet, at least initially, will have results. The problem is that, over time, your body is making ketones. Acetone is a ketone. Acetone, right? Acetone is a great solvent, but not something that you want to have in your body. Okay? So, in addition to being potentially carcinogenic, it's hard on our kidneys and liver, right? So, people who undergo ketosis for a prolonged period of time can have issues with their organs. Okay, as a result. So, the old adage, everything in moderation, right? Probably is true. Okay. So, here are some examples of aldehydes and ketones, right? So, formaldehyde from ethanol, acetone from lipids, essentially. But our hormones, right? Our hormones are ketones. That's why they're called hormones. Progesterone, testosterone, right? And so right here, right, that's the ketone. Here the ketone is in the ring. Aldehyde, so vanillin and benzaldehyde, right, those are going to be in things like, lots of things have vanillin actually. And I know that we talked about the sugar pines, right? Yeah. Right, so they have vanillin, they have benzaldehyde, and so that's what gives it that aroma. And you can see that these are pretty, like this is a very simple compound to make. Yeah. This is pretty simple as well. And so you can buy vanilla extract, you can buy almond extract, or you can go the cheaper route and you can buy vanilla flavoring and almond flavoring. Right? The extract comes from the raw material. Flavoring comes from synthesis in the lab. And it's very cheap to synthesize. And so that's why you can get that for much less money than extract. Cinnamaldehyde, did you guys do a lab where you had unknowns?
Yeah, that was our, we did a lab like that, and we also did like our final.
Okay. It's a small class, but maybe one of you had cinnamaldehyde. It's not a great one as an unknown because all you have to do is, oh yeah, that's cinnamon, right? But that's what you get. Carvone, that's spearmint, and it essentially antagonizes the same receptors in your tongue as capsaicin. Capsaicin is drink water, the water feels really cold. Have you guys noticed
Yeah.
that? Right?
Yeah.
Mint makes the like temperature feel cold. It's not though. It's not cooling down, right? It's that our receptors in our tongue are antagonized by that carbone. And it turns out that carbon dioxide does the same thing. So carbonated beverages, my kids they all call them spicy water. And I was like, spicy water. And I thought it was just because it was bubbly, but then at some point I realized that I was reading somewhere, it's like, oh, it triggers the same receptors that capsaicin and carbone do. And so, my sensors are probably not as sensitive because I'm eating hot foods and this a lot more. If you're a little kid and you have spicy water, it probably is
Spicy water.
spicy to the intestines, right? And so that's why they call it that. And if you ever give a really young, not like an infant, but like a neat, not quite a toddler, but someone who can drink. Like, if you ever give them a little spicy water, it's just like, just like, because it probably is to some extent spicy. So these are everyday common examples of ketones and aldehydes that we cross in our lives. So they're very relevant to biochemistry. For naming, we're going to basically, fulfill the same criteria as what you're used to. You find the parent. The parent is the longest continuous chain of carbons, right? And then from there, you see if anything is branching off. Are there any substituents coming off? And if so, where are those substituents located, right? And our longest chain is what's going to contain that aldehyde or that ketone functional group, right? Because we're getting to the point now where molecules are going to get more and more complicated, right? So we have to pick something to be the parent, and that won't be necessarily a parent, which one is that case. So there are rules, and I'll be the first to admit I've forgotten probably more rules than I remember, but there are hierarchical preferences for things like, if you have an aldehyde and a ketone, which one is the parent?
I was gonna ask testosterone. I think had the ketone and the alcohol group on there. So I was wondering why it wasn't testosterone or something.
Yeah, right. So in this case, it's probably because the ketone takes precedence.
Okay.
And it also is sometimes because it's easier. So this isn't the IUPAC name, right? This is the common name.
Sure.
In fact, I don't know. We could see what Molview says if we put testosterone.
Oh, okay.
It's probably going to be
Ketone or no.
messy, just to say.
Don't put it on the midterm, please.
Yeah. Ooh, yeah.
Oh, wow.
Okay. But look.
Yeah.
Oh. So the ketone still takes precedence now. Hydrocyclopenta.
Or hydroxy.
Oh, hydroxy. There, yeah, that's it, right? Yeah.
Wow. Yeah, that would be a really tough one.
This will be on the final.
Oh, man.
So yeah, I mean, the IUPAC, of course, gets way more complicated than what we're going to ever need to use at this level. But and then we alphabetize the substituents, and I know that Sean's not a big stickler for alphabetization, right? Like as long as you can draw the structure from the name, that's good enough for him. I came from a background where it had to be alphabetized, so that was my training. But then after talking with him, like, it's fine with me. So. If you were to take OChem somewhere else, be aware that alphabetization may matter, right? Or the MCAT, that kind of thing. Alphabetization might be the difference between a right answer and a wrong answer. But for this class, I don't really care. As long as it's on the right locant, right? As long as I can draw the structure from that name, it's good.
Okay.
All right, so what is the suffix for this? It's going to be al. Or it could be, so if we have a ring, we call it a carbaldehyde. Okay. So this is cyclohexane. But because it might just be because we don't have a good aldehyde or ketone prefix, right? So that's why they tend to take precedence over something like alcohol, which would be hydroxy, right? So if we have this ring, typically if that wasn't there, right, or if it was just like that, we would call that, so if it was just this, well, it wouldn't be toluene because there's no pi bonds, right? So these would have to be hydrogens, and we just call that methyl cyclohexane. This would be the parent, but because we have an aldehyde on there, we call it whatever that ring is, and then followed by carbaldehyde. You could also call this butanaldehyde, and that wouldn't be wrong either. Butanal, though, this suffix al is short of an aldehyde, so right, it's more convenient. But if you were to write butanaldehyde, that wouldn't be wrong. Just okay. And then looking at ketones, same kind of thing, right? Identify the longest continuous chain that includes the ketone in it. That gets dicey because sometimes you have a longer chain, but it doesn't have the ketone in it, right? So that doesn't become the parent. It's the one that has the functional group embedded into that chain that's going to be your parent, which then decides whether it's a meth, F, prop, but, etc. Then we give it a position, and again, alphabetized or not, and the suffix is own. Right? So in this case, it's kind of like couple different ways to do this, right? We could say, okay, the longest chain is 7, so that's a heptane, right? But since it has a ketone in it, we'll call it 3-heptanone, because it's on the 3rd carbon. Or oftentimes you'll see heptane 3-one. And this is the newer IUPAC version. I think this is, for some reason 1995 is sticking out, but I don't know why. So at some point they incorporated this, and that's only helpful for when we have a lot of substituents coming off and the numbers. It's easier just to embed it here so that it's not being confused with a locant for some other substituent. Either way, you can do that. Or if you think about how ethers are named, oftentimes you put the chains on either side of the ether and you embed that into the name. So we could call this 1, 2, 3, 4, 5, 6. We could call that 3-hexanone. Or in this case, they're saying, okay, well, there's an ethyl group and there's a propyl group, ethyl propyl ketone. Okay. I don't really like that. That's just, but it's your choice, right? That's not incorrect.
Is that an older method, or?
I think that's an older method, right? Yeah. So older, younger, youngest. I tend to do this, but either one of these I would say would be preferred. But you might, I put this here because you might see it that way, and that's perfectly acceptable as well.
Would the ethyl propyl ketone count as like an IUPAC name?
No, I would say that these are the IUPAC names. This is probably a common name. Before IUPAC was established. All right, so let's do some practice. First thing, just identify what we have going on here. So this, right, here is our carbonyl, hydrogen. That tells us it's an aldehyde, right? So we always want a number to keep that aldehyde as low as possible, okay? So we don't go this way, right? We want to, because that's the parent, we want to keep that number low. So it's going to be 1, 2, 3, 4, 5, 6, or 6, or 6. It doesn't really matter, right? But 6. So it's a hexanone, right? And it's on the first carbon. And so if that's the first carbon, then we have 2 methyls on the second, and we have 2 bromines on the fifth. So we could call this, what, 5,5 dibromo, 2,2 dimethyl hexanol. Yeah, because it's an aldehyde.
Would you say like 1? You'd have to still like say.
You don't have, if there's no number,
you assume.
then we assume that that's on the first carbon.
Okay.
And that's a little bit of a philosophical thing. I think you could put the 1 there. In some cases, I do see 1s put in there, but if I don't see a number, then it's 1. Now, with B, we clearly have a ketone, and it's going to be on the second carbon, right? Longest chain, 1, 2, 3, 4, 5, 6, so another one, right? So this is going to be hexanone, but we have stereochemistry here. Oh, we haven't done stereochemistry in this class together, right? Because benzene rings, there's really hardly ever stereochemistry. There can be, but okay. So did you guys remember R and S?
3R, yeah.
Okay. So let's number this 1, 2, 3, 4, 5, 6. And let's write this name. We said this was 5,5 dibromo, 2,2 dimethyl hexanal. Okay. This is hexanone. Oh, hexanone. Hexanone, no. There we go. Hex and none. There we go. And we do need to put a number there, right? Because it's on the second carbon. Mm-hmm. And then we have 3 methyls, right? Mm-hmm. So 3, 4, 5. Trimethyl. So trimethyl, and it's going to be 3, 4, 5, and then we need to assign our R and S. So here, right? Let's do this carbonyl is going to take preference,
yeah.
Right? So that's going to be 1, And then this one is going to take preference because it, you know, because right, we go out to the next carbon here, right? It's got more stuff. So that's 2 and that's 3. So we're going counterclockwise. However,
that's in the
where's the
background.
hydrogen?
Yeah.
We got to get that hydrogen into the wall. So it's going to be the opposite. So if we are counterclockwise, that is S. Okay. Clockwise, R. So we're counterclockwise, but we've got to flip this. So that's going to make this R. So that third carbon, so we got 3R. And then here, what's going to be our, oh, I got black, yeah. What's going to be our 1?
Be towards the carbonyl.
Exactly. So 1, and then
So like 2.
Yeah.
And then the methyl group is 3.
3.
Yeah.
So we are going clockwise, but
Still backwards.
still backwards. So clockwise would normally be R, and it's going to be S this time.
Cool.
So 3R, 4, right?
S.
Yes, 4S.
Cool.
Trimethyl 2
Hexagon.
hexagon.
Okay.
C. Ooh, we got a cyclo, right? So the ketone is in the ring. So in this case, we can use that as the parent, right? When the ketone is not in the ring, then the ketone is the parent and it's just a cyclo, whatever substituent, right? But in this case, we have a cyclopentanone. Because they're 1, 2, 3, 4, 5, right? Cyclopentanone. And doesn't matter which way we number it, but the ketone group gets 1. And we can go 2, 3, 4, 5, or 2, 3, 4, 5. Either way, it's going to be a 2, 2, 5, 5. Right? Yeah. 2, 3, 4, 5. Tetra methyl cyclopentanone.
You just assume it's at number 1 because there's
Now in this case, it's not at 1, right? This is going to be an al because it's an aldehyde. Paul Simon, you can call me Al. You guys know that song?
Familiar with it now.
It had a MTV music video, which you may remember MTV when it
remember.
actually played music,
Yeah,
but
I was a little.
it had, you guys know Chevy Chase, the
Oh, yeah.
actor?
Yeah.
He was in that music video. Anyway, 1, 2, 3, 4. 1, 2, 3, 4. Doesn't matter. Either way, it's 4. 1, 2, 3, 4, 5, 6, 7. So hept, right? Heptanal. I don't know why I put a, oh, I know why I put a 7 because there are 7 carbons total. 4. 4 heptanal. Or what else could we do?
So where the carbonyl attaches to the carbon, that's part of the functional group. It's not the locant.
Oh shoot! No, you're right. That's not right. Because it's right here, right? It's not in the. It's got to be in the longest chain. So I erase that or strike that. Strike that from the record.
Okay.
2, right? 1, 2, 3, 4, 5.
Mm-hmm.
1, 2, 3, 4, 5. So it doesn't matter which way we number it. All right. Yeah, that's better. So this is a 1, 2, 3. So propyl.
2
Coming
propyl.
off the second carbon. So yeah, 2 propyl.
Heptanol?
Pent.
Or yeah.
Right? Yeah, pentanal. 2 propyl pentanal.
Okay.
And then another one you got to be careful of, or I have to be careful of, I guess. This is not part of the ring.
Mm-hmm.
Okay? So remember when we had something coming off the ring, we said whatever the ring is, and then carbaldehyde. Okay? So in this case, we have a ring of 4 carbons, so cyclobutyl carbaldehyde. Cool. All right. Can I erase this?
So carbaldehyde is just like a 1 carbon
Yeah.
chain with that? Okay.
If it came further off, then you would just call it whatever that chain was, right?
Ethaldehyde or something?
Yeah, so we had
Mm-hmm. 1, 2, 3, so
1, 2, 3,
propaldehyde?
or propanol.
Propanol.
So we call this cyclobutyl propanol. Okay, I think we can probably put a pin here. The next slide is just doing the opposite. It's giving us a name and asking us to draw the structure. So my recommendation is between now and Thursday, work on those mechanisms, right? From the previous, I think there was a previous slide. Work on nomenclature. We'll come back Thursday, go over it together. In the meantime, let's take a break. I will print off the practice midterm. Do you want to just meet here?
Sure.
Or you want to meet in the lab?
Probably
Yeah,
here, yeah.
Let's just meet here at 1.
Okay.
Okay.